Okay, first order differential equations would be equations with a first derivative. The order of a differential equation is its highest derivative. So second order would be second derivative, third order would be third derivative. Linear differential equation. Linear means that the derivative of y is not being multiplied by y anywhere. So linear in algebra is when you have the power on the variables equal 1. Linear in differential equations means if you look at the derivative, it's not being multiplied by any y. So x cubed counts like a constant in this case. So it doesn't really count. When you say linear, you look at y, you look at y prime. If it's first order, there's only one derivative. And you make sure they're not multiplied in any way. If those are multiplied, then the problem becomes a bit more tedious to solve, and that's our chapter 12. If I have a first order, meaning I have one derivative, first derivative. Linear means y and its derivatives are not being multiplied, which means I could solve this. Any first order linear differential equation can be solved. If I look at example A and example B, I'll notice that those are not separable. I can't separate the x from the dx and the y from the dy, so I can't put the y with the dy and the x with the dx and integrate like I did in the previous section. But somebody made this observation. If you were to look at this for a while, you'll notice that this is the product rule. You'll notice that x cubed times a derivative of y, and 3x squared is the derivative of y cubed, and y prime is the derivative of y, indicating that, look, somebody must have taken the derivative of x cubed and a y. If I take a derivative of this with respect to x, of course, then that's going to be derivative of the first 3x squared times y, it's right there, plus x cubed times dy dx right there. This is differentiation. So somebody made the observation that this is the product rule, and if you take an antiderivative with respect to x, then the antiderivative will undo the derivative, and you're left with x cubed y equal. This is x squared plus c. So y would equal x squared over x cubed. That would be 1 over x plus c over x cubed. So this is really the solution to this differential equations. If you take a derivative of that, multiply it by x cubed, take this value, multiply it by 3x squared, you will get a 2x. If you have time, you should work this out and make sure that you're convinced, because that does work. And somebody made the same observation here. Somebody looked at this and says, wait a minute. If I take a derivative of this, that's this right here. And if I take a derivative of this, that's this right here, which indicate somebody must have applied the product rule. Somebody must have taken the derivative of, and again, x squared plus x to the fourth times y. So if I integrate with respect to x, that would be undoing the derivative. This and that will cancel out. That will be x squared plus y plus x to the fourth times y will equal 7e to the x plus c, and y would equal 7e to the x over x to the fourth plus x squared plus c over x squared plus x to the fourth. Now, like we mentioned, first order means first derivative. Linear means y and its derivative are not being multiplied in any order. Somebody came up with a way of solving any of those. If I happen to have a first order, meaning first derivative, linear differential equation in which y and its derivatives are not multiplied or divided in any way, make sure you have a 1 right there. That's going to be a key for many of our theorems in differential equation, chapter 11 and 12. If I let u equal e to the integral of whatever is being multiplied by x, and if we multiply equation 1 both sides by u, we will get u times dy dx plus u times py, and you multiply this by u, then this left side would become simply the product rule. And you could apply the trick that we applied up there. And that's how it works for all of those. So what's the catch? Solve the linear. The key is for you to see the word linear. That's a hint. Make sure that's a 1. You make sure that's a 1. If that's a 1, then you could say that's p of x right there. So if you let u equal e to the integral of negative 3 dx, that would be e to the negative 3x. That's your u. Multiply this by e to the negative 3x. That will be e to the negative 3x dy dx minus 3e to the negative 3x times y equal just x. And do we agree that this right here is really the product rule? That is, somebody must have taken a derivative of e to the negative 3x and a y. If you take the product rule, derivative of e to the negative 3x is e to the negative 3x times negative 3 times y plus e to the negative 3x times y prime. And now that I'm able to do this, I can integrate and say e to the negative 3xy equals x squared over 2 plus c. And if I want y by itself, I'll divide by e to the negative 3x. That will be x squared over 2. When you divide by e to the negative 3x, that's like e to the 3x. And there it is. And by doing this trick, I'm able to solve the differential equation in which I wasn't able to solve before. Same deal here. This is a linear differential equation because y prime and y are not multiplied in any order or added or anything like that. Make sure that's a 1. Added is fine. Multiplied or divided. So if I can't solve this, but if I let u equal e to the integral of 1 over x, u will be e to the natural log of x, u will be simply x. So if I multiply this whole equation by x, that will be xy prime, the x's cancel out, plus y equal x squared, the sine of x. And now I know this is the product rule, so this is xy prime. And you could check, if you take a derivative of that, you'll get this, equals x squared sine of x. And if I integrate, again with respect to x, I should say, xy will equal, so u equal x squared, 2x, 2 and a 0, dv equals sine of x, cosine of x, negative the sine of x, and cosine of x. So positive, negative, and a positive. That's going to be x squared cosine of x plus 2x sine of x plus twice the cosine of x plus c. If I divide both sides by x, I'll get x the cosine of x plus twice the sine of x plus 2 the cosine of x over x plus c over x. That would be my solution to this differential equations. And if I look at the next problems, make sure that's a 1. That's always the case. Not in this section, in any section. Well, this is a first order linear differential equation. I'm gonna let u equal e to the integral of 3 dx, so u is going to equal e to the 3x. I'm going to multiply this by e to the 3x. That will be e to the 3x times dy dx plus 3 e to the 3x times y equal x e to the 3x plus e to the 4x. And here, I am guaranteed that this right here becomes a derivative of e to the 3x times y. And if I integrate with respect to x, this will be e to the 3x times y equal e to the 4x divided by 4. And here I could let u equal x, du is dx, dv is e to the 3x dx, integrate v is e to the 3x over 3. So that's going to be x e to the 3x over 3 minus the integral of this, that's going to be e to the 3x over 9 plus c. If I divide by e to the 3x, I'll notice that y will equal x over 3 minus 1/9 plus e to the x over 4 plus c e to the negative 3x. And d, the same deal. I look at this, say, wait a minute, I can do this. I'm going to let u equal e to the integral of, and again, there's y prime. Make sure, oh, it didn't move. Make sure that's a 1. P of x is the sine of x dx. So u is going to equal e to the cosine of x negative. Kind of odd. Okay. So, if I multiply this by e to the negative cosine of x, both sides, I'm going to get e to the negative cosine of x y prime plus y e to the negative cosine of x times sine of x equals e to the negative, and let me make sure that's right. Yep. E to the negative cosine of x times sine of x. I was checking if I take the derivative of e to the negative cosine of x times y. So let me do that on the side. If I take this derivative, the derivative of the first times derivative of that is the sine of x times y plus e to the negative cosine of x times y prime. And yeah, it matches perfect. The right side is e to the negative cosine of x times sine of x. If I integrate with respect to x, I'll notice on the left hand side I will get y e to the negative cosine of x. On the right hand side, if I let u equal cosine of x negative, du is sine of x dx. So this is nothing more than the integral of e to the u du. So that's e to the negative cosine of x plus c. So y would equal, if I divide by that, y would equal 1 plus c e to the cosine of x. And that would take care of that problem. A couple more to go. Actually, 3 more to go. That's okay. So here, the same deal. I look at this. I make sure that's a 1. And it is a 1. So here, I'm going to let u equal e to the integral of negative cotan of x dx. So u is going to be e. And this is going to be, if I remember correct, that's negative natural log of sine of x. Make that a power. So u equal e and natural log will undo each other. 1 over sine is the cosecant of x. So if I multiply this by cosecant of x, I'll be looking at cosecant of x y prime minus cosecant of x cotan of x y equal cosecant squared of x. And I am guaranteed that this would be a product rule. That's the whole purpose of this. This will be cosecant of x times y. And again, take the product rule and you'll get this. Integrate with respect to x, I should say. And here I'm going to get the cosecant of x times y. And this will be negative cotan of x plus c. So y would be negative. This is cosine over sine. And this is y over sine, so times sine of x plus c, the sine of x. Those cancel out, and that would be my answer. Y would be negative cosine of x plus c, the sine of x. Here, I would notice that this is not a 1. I forced that to be a 1. That's simple. And I'm looking at y prime minus 2 over xy equal x cubed sine of x. Here, I'm going to let u equal e to the integral of, again, there's p of x. U is going to equal e to the negative twice natural log of x. That becomes a power. U is going to equal e to the natural log of x to the negative 2. U is going to equal 1 over x squared. So multiply this by 1 over x squared. This becomes y prime over x squared minus 2 over x cubed times y equal x sine of x. And this is guaranteed to become the derivative of, let me think, 1 over x squared times y, or y over x squared. So derivative of x to the negative 2 that works. And if I integrate with respect to x, I will get y over x squared equal, and here, if I let u equal x, du will be dx. Oh, lovely. And dv will be the sine of x dx. V will be negative the cosine of x, so u times v minus the integral of v du. The integral of negative cosine of x is negative the sine of x. Let me see, u times v minus the integral of v du, so plus sine of x plus c. And if I multiply by x squared, I'll get y to equal negative x cubed the cosine of x plus x squared the sine of x plus cx squared. And that would be my final answer. And if they gave me initial conditions, I could actually figure out what C is. And here we are again. This is a first order differential equation that is linear because those are not multiplied. I'm going to let u equal e to the integral of 2 dx. U is going to equal e to the 2x. Multiply this by e to the 2x. That will be e to the 2x y prime, an awkward looking x, plus 2e to the 2xy equal, if I multiply this, those under each other, that's x. This is e to the 2xy prime equal x. Integrate with respect to x, and I will get e to the 2xy equal x squared over 2 plus c. So I could say that y equal x squared e to the negative 2x over 2 plus c e to the negative 2x. Since they told me that when x equal 1, y equal 0, I could figure out when y equal x equal 1 squared times e to the negative 2 over 2 plus c e to the negative 2, right? So negative e to the negative 2 over 2 equals c e to the negative 2. If I multiply by 1 over negative 2, I'll get c to be negative 1/2. So I would say y equal x squared over 2 e to the negative 2x minus 1/2 e to the negative 2x. And that would be my explicit solution. And that's pretty much it for this section.